right, so lab one went really well. Hopefully you got introduced to your development environment, the grading process, of course, as well. And everybody did a basic hello world program, basic output program. All you're doing is printing stuff to the screen. Before we get any more complex, though, I wanted to demystify that process a little bit, because all we had to do was compile. You started from source code that looked something like this. And then you immediately created an executable file, a.out, that you can immediately run. It's not that simple, right? Instead, there's an entire process that goes on behind the scenes that the instructions that we gave you makes all that opaque. You can't see it. So what I want to do is I want to, just as a demonstration here, show you what the basic process is for a C program. You start, of course, with plain text source file. It's not, we call it plain text because it's not a Word file, it's not a rich text document or anything like that. It's just plain old text, right? In a particular computing programming language. This is true for almost every single programming language, the vast majority of them at least, right? If not all of them. But a computer doesn't understand that language. Instead, you need to transform it in a way that the computer does understand that, because a dumb computer is only understanding zeros and ones. It's a bunch of wires and a bunch of electronic signals sending out binary. High for or 1, or high voltage, or whatever, however you want to represent it for a 1, low voltage for a 0, right? So you start out with source code, and then it goes through this process called the preprocessor. We'll take a look at that later on. But then it takes that code and puts it into what's called assembly language. Assembly language is not something that not intended for humans, and it's also not something that is immediately understood by a machine, by a processor. Instead, what you need to do is you need to take that assembly language and then transform it into machine code. Machine code is just pure zeros and ones. That's the only thing that the machine actually understands. So what I want to do is I want to show you that process over here really quick. You're not going to have need to do this manually. Instead, you're just going to compile immediately. But what I'm going to show you is, let's go ahead and see what assembly language looks like. So I'll go ahead and compile this into, or I'll assemble this into assembly language using the special flag S. Don't worry about it again. You're never going to have need to actually do this. No news is good news, right? So it actually assembled it. Now I need to refresh my window over here to actually see the file that was created, and I'll see this hello.s. That's an assembly language file. Let's go ahead and open that up, okay? Not exactly English, right? It's not easy on the eyes, right? If you look over here with the Hello World program, you can kind of tell just plain old English of what it's doing, right? We've got a message here, right, that tells you what it does. But even the code right here, Printf, well, you understand what printing means, right? It's going to print something out. And what is it going to print out? Well, probably hello world, even if you didn't know that this is an end-line character here. But this is pretty unreadable, right? This is getting closer to what the machine understands, but still not there yet. Some of this stuff is still intact. For example, let's see, where is that? There's that hello world message that we're actually going to print out. And it's a string, right? But otherwise, this is assembly code, right? This is what it looks like on its way to becoming machine code. Now let me go ahead and create this machine code, right? I'm going to compile, but not into an executable file yet. What I'm going to do is I'm going to compile this into machine code, and it's not something that we're going to be able to read. In fact, if I refresh this over here and I try to open this, it's even going to warn me. This file is not displayable in this text editor because it's not text. It's a bunch of binary. It's a bunch of zeros and ones. Right? That's okay. I can go ahead and use a tool called hexdump. S, I think. Hello dot, oh, let's go. Oops, nope, it's not S. What is it? C, there we go. There we go. That's what it actually looks like. Just a bunch of numbers. This is completely unreadable to us humans. But this is what the actual computer understands. Right? Now, some of it is still left intact. For example, if I scroll all the way up here, you'll see that hello world message right there. All over on the right here, that's its attempt at trying to interpret it as plain old text. And of course, if it is plain old text like hello world, it actually does render it correctly. But otherwise, everything else is just a bunch of zeros and ones, so it doesn't know how to interpret it. Okay? This is basically the history of computing. If you go back 60 years before the modern computer, people were literally making punch cards of zeros and ones. They were writing in machine code. Now, they didn't start immediately writing in machine code. Instead, they came up with their program, and then they manually translated it by hand to machine code. They realized that that's a tedious process, error-prone. We don't want to do this. So they created assembly language, which is something that a processor does understand a little bit, like take this value and put it into into this memory location, take that thing in that memory location and move it over here if the thing in that memory location is greater than 0, right? That's the kind of language that assembly language is. Right? That still wasn't good enough, right? Because, well, we want a higher level programming language. We want to program in English. Now, that's the ideal, right? Natural language, whatever your native language might be. We're humans. We want to speak human languages. So they introduced higher level programming languages like C. It's not exactly English, but at least it's readable to a human, right? Now, more languages were introduced that are a little bit less like machine-like and more human-like, until eventually, hopefully, we will be able to program in just plain old English. We'll be able to tell the computer exactly what we want, and it'll do exactly it'll interpret it exactly correctly, and it'll do what we want. Despite the hype, ChatGPT and other tools still are not there yet. Right? Okay. So that's a little bit of a demonstration. Right? And we'll come back to this preprocessor bit here in a moment. What I want to do is I want to turn our attention to a more complex program. So before I even open this, in fact, let me go ahead and just ask you, KMS to mile. The file name, what does that indicate? I'm going to be converting kilometers into miles, right? Let's open it up. Now, you don't know any code yet at all, right? So don't bother reading the code. Instead, let's go ahead and read up here. What does that say? This program converts miles to kilometers. Plain old English, right? That's our first part of this program here. Here's an anatomy of a program. The first part is our author header. Just like if you were in an English class, and you were writing a 5-page essay or a 5-paragraph essay or whatever they do now, what are you going to put at the top? Your header. Name, date, right, et cetera, et cetera. And for us, that's also going to include a purpose of the program. By the way, is this big enough for everybody in the back? Good? Okay. Let me know if I can increase it a little bit, right? All right, so this entire thing right here is a comment. A comment is a human-readable message to other programmers, to other developers, and in fact to yourself. Because if I came back 3 months from now, and I didn't have such a good file name of KMS to miles here, I would wonder, what is the purpose of this program? If I don't have that there, what am I forced to do? I am forced to start reading every single line of the program to see, oh, I declare my variables, okay, for what? Well, miles and kilometers. Does it convert miles to kilometers or kilometers to miles? Which one is it? I have to read, they prompt him, the user to enter miles. And then I read the miles in, and then I compute the miles per kilometers per mile, et cetera, et cetera, et cetera. Right? I would have to walk through this entire program to understand what it does. Instead, I have this nice documentation up at the top. This author documentation tells me the purpose of the program, so that I'm not having any guesswork there. Right? So we're going to look at the basic framework of a program starting there. Comments, again, are human-readable messages embedded in code. They are ultimately ignored by the compiler. No effect on the end program. Because what happens when it gets compiled is all these things are deleted and thrown out. It's still in the source code that you originally wrote. Good, because if you want to maintain the software, you need to go back and reread stuff. But it's not in the end program. When I compiled this into, I didn't have any comments in that file, but when I compiled it over here to hello.s, there would be no comments there retained at all, just metadata. Right? So it's ignored by the compiler, has no effect. We've seen a couple of comments embedded in that program so far. You have single line comments, which begin with a // Is that a forward slash or a backslash? Remember, I'm facing this way. Am I leaning forward or backwards? I'm leaning forward, so we've got // Everything after this on the same line is ignored. Let me go ahead and go back over to our program here. Get rid of that one. How do you know that it's being ignored? What kind of visual cue is this IDE giving you? Right? There's a comment. How do you know it's a comment just by looking at it? Just by looking at its formatting. It's all grayed out, right? It basically has no effect, and that's the impression or the intuition that syntax highlighting is trying to give to you. Right? I can have an executable statement here like this, and then I can put a comment after it. This is a comment, right? But this is not. Why? Because it's a single line comment. It only ignores everything all the way to the end of the line. When you go to the end of the line, it is no longer a comment. That's okay. If you want multi-line comments, then you can start it with a /* as long as you end it with a /*. In fact, that's so common. Did you see what my IDE did for me? If I'm going to open up a comment, it automatically closes it for me and inserts those characters. Anything you put between these two symbols is ignored. It is a comment on multiple lines. There we go. All right. So that's a multi-line comment. So multi-line comments begin with a /*. Multi-line comments begin with star or /* and end with */. Right? You can also have doc style comments. These are multi-line comments, but formatted with a vertical line of stars. All right? So let me go back over here and show you what I mean by that. All the way up here at the top. The other thing that it's that is the convention is that it's /**, and then it ends with a //. It's no different than any other multi-line comment, but by formatting it like this, I've got this nice vertical line here that gives me some documentation. Right? It's very nice and easy to read and nice on the easy on the eyes, I should say. Right? Get into the habit of writing document-style comments for author headers, and then later on when we write our own functions, every function will need a doc-style comment. Right? Just get into the habit now. Why? Because if you do, I'm not sure about this one, but let's go ahead and try it automatically. There we go. Right? If I start writing, hello, how are you? Right? You see what it's doing for me there? It's such a universal convention that it's automatically going to format it for me. Not perfectly, but almost perfectly. Right? There we go. Undo, undo, undo. Let me restore my author header there. Perfect author header. Okay? So what are the purpose of comments? Right? So again, if I come back 3 months from now, and my program is 10 times more complex, 100 times more complex, am I going to remember every single line of code that I wrote and the purpose of that comment or the purpose of that code, et cetera, et cetera? No. It is a message to other developers, other software engineers, other programmers, whatever you want to call us, on why you did that thing, okay? Especially documentation. It's intended to tell the user, in other words, other programmers and the future you, why did you do this? I wrote it because I wanted to convert kilometers to miles. And the how. How did you do this? Well, I read it in from the user and I output it and et cetera, et cetera. Not the what. The what is embedded in the code itself. Right? So let's go ahead and take a look back over here. Let me go ahead and get rid of this because that was just an example. Now, arguably, I've got really bad comments here. Right? What I've done is on these first 3 lines right here, I've commented every single one of them. That's only because we're starting. I'm going to comment things and tell you what this does. If you can take, at the end of the semester, you'll understand that these are variable declarations without even having to look at this up here. Right? This is an inappropriate comment after the week 2 or 3. That should not be there. Right? It's only there to tell you what this program is doing throughout. Right? What ideally this should look like is none of that stuff is there. Right? There we go. And I've gotten rid of all the comments. Why? Because the code should be self-documenting. That's a variable declaration. That's a print statement. It's prompting for input. That's a read statement. That's a mathematical formula that's multiplication, et cetera, et cetera, et cetera, right? That is self-documenting code. If you've got really complex code that you can't just tell what it looks, what it's doing just by looking at each line, an experienced person, then that's when you need documentation. So let me go ahead and undo, undo, undo. The code should be self-documenting. In other words, the code should tell you the what automatically. Otherwise, if it doesn't tell you what it is automatically, then it's either bad code or it requires documentation. Okay. All right. What do you see in this program next after my header documentation from lines 1 through 6? We've got these things here. Include. That's English. What does that mean? I'm going to include this standard library, right? And we can even kind of read that, especially since I told you what it was on Monday. We can also include this standard input-output library, right? I/O is always going to be input-output. Right? We've also got this thing right here, define. The three commonalities of these three lines is what's this symbol right in front? Hash. The symbol itself is a hash, but we all know it as hashtag because of social media, right? So a little bit of trivia. Why is it called a hash? First of all, what is a hash? So what do you do with potatoes to make them nice and tasty? Like hash browns, right? Ever eaten hash browns? Dump a bunch of ketchup and a hot sauce on them? Great. Well, how did they get that way? You cut them up, and then you cut them up the other way. Hashing, cutting them up like that, is the act of hashing, and that's where that symbol comes from. So that's a hash, right? And it's saying, please include this library for me. Please include this library for me. And then this is what's called a macro. We'll talk about that in a second. Okay? So those are all what are called preprocessor directives. They're macros that are executed before the compiler compiles your code. Now, what is a macro? A macro is an action that you can record and then repeat. So if you've ever worked in Excel before, right, and you do action, 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 what you can do is you can actually record those 4 actions and then put it into a macro so that all you need to do is hit a button and it repeats those 4 actions for you so that you don't have to do all those 4 actions every single time. That's what a macro is. A macro literally is a cut and paste in this case. Include brings in a standard library, right, an external or standard library, so that you don't have to code from scratch. It is literally going out to that library, cutting and pasting code, and including it in your file, right? So that you don't have to have this big giant file, one file with thousands and millions of different lines of code. You can separate things out into different libraries so that you can focus on the work at hand. That's what an include does. What about define? Well, what does define in plain old English mean, right? Defines, of course, an alias that can be used in place of magic numbers. Right? So rewind your brain and pretend that you don't know the purpose of this program. Right? If you just look at this one number in isolation, 1.60934, do you know what that number represents? No. Some numbers are universal. For example, if I said 3.14159, what am I obviously referring to? Pi, right? Just an inaccurate pi. If I said 2.71, what am I might be referring to? There's either less common answers there. E, right? If I said 0.12345678910111213 and went on, anybody know what that is? That's the Champernowne constant, right? Who cares, right? I don't want to have to remember these numbers in my head. We all remember 3.14159, whatever it is. I don't even remember it now, because it is used so often. But this is not used all that often. So what I've done is I've defined an alias. Instead of using this magic number, we call it magic because where did it come from? Poof, it exists, right? I'm going to give it a name instead. KMS per mile. That's a lot more readable than 1.6 blah, 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 right? I'm giving it a human readable name. Now what happens is the preprocessor goes through my program, and any time that it sees KMS per mile, it literally does a cut, paste. Right? So it has the effect of me using this magic number in my code, but I can use human readable terms for it instead. Not only that, but another advantage. I don't know how to make this more precise, but let's just say that the next digit is 2. Right? Now, if I had used this number, 1.60934, 50 times throughout my program, and I want to make it more accurate by adding a 2, guess what I'm going to be doing? I'm going to be tracking down all 50 of those places where I was using it and changing each and every single one, crossing my fingers that I don't miss any of them and that I don't mistype a 2 as a 3 instead. Right? If I collect all those in one place, then the preprocessor takes care of everything for me. Right? This ends up becoming a constant. The number of kilometers per mile is not going to change anytime soon. 3.14159 is not going to change anytime soon. So it is much more appropriate to put it in a preprocessor directive like this. In fact, there's another one. If you do want pi, you would have to have the math library's pi definition. Right? So I've done all capital letters here with an underscore separating different words or different symbols. That's defined in the not in the standard library, not in the standard input-output library, but what do you think? The standard math library. It's not STD math, it's just math. Right? So eventually you will have to be doing math or mathy stuff, and you'll want to use that library. Because you don't want, anybody want to write their own cosine function? No. Right? That's why we have calculators. You hit cosine on your calculator. How does it work? Think smart aleck answer because that's the correct one. Who cares? It just does, right? The math library takes care of all that stuff for us, right? All right. So define defines an alias that can be used in place of magic numbers for 2 purposes. You can replace magic numbers with human readable text, and only one change is necessary instead of the many, many, many changes. Okay. I've cleaned this up a little bit. Good. All right, so what's next? So if you set up a bunch of dominoes, right? Everybody's done this at one point in their lives when they were kids at least, right? Set up a bunch of dominoes so that you can knock one down, right? Well, what is that act? Hopefully you don't do that until they're all set up. Why? Because that's the starting point. The main function in any programming language is going to be the starting point. Any program has to be started at some point, right? So for C and for the vast majority of programming languages, you have what's called the main function, right? So the main function is always the starting point for any executable program in C. This is also true for Java. It is semi-true for Python. Python, you can just go ahead and start executing an interpreted script, but you can also define a main. Pretty much any programming language that I've ever seen has some way, either requires a main or has some way of you defining a main. For now, argc and argv are magic. Right? Ignore them for now. Ignore for now. And what they are is actually command line arguments. That's what the arg stands for, argument. C stands for count, how many did you have? And V stands for vector, the actual arguments. We'll get into non-interactive input after we've gotten past interactive input. Right? What do I mean by interactive input? Let's go ahead and go back and actually compile this now. If I compile GCC, kilometers to mile, et cetera, and I run this program, what would you expect to happen first? Well, there's no way that this is output right here, right? This is just creating variables, which we'll talk about in detail later. Then it prints something. What do you think happens after I prompt the user for input? Let's find out. It sits there and waits. It sits there and waits for me to type something, right? So do we have any runners out there? Okay, so it's way too hot this week. So I went on a treadmill this morning for 5 miles. How many kilometers did I run? About 8, right? Far less than usual. But if you're interested, I ask if you're runners because we hold a weekly, or not weekly, we hold a monthly run with SOC faculty 5K. The first Monday of every month. It'll be announced in Bits and Bytes soon. The first Monday of every month, 9 a.m. So if you're interested, come along and run with us. We just run all the way around campus. Shouldn't be too hot at that point next week or whatever it is. I guess 2 weeks from now. Right? All right, anyway, it read my input. I gave it 5, and then it computed the kilometers, and then it output them, right? Blank miles is equal to blank kilometers. I'm saying blank here, but these are called placeholders. Again, we'll get to that later. Okay. So this is interactive input. The computer asks me for something. It sits there and waits until I type and hit enter, and then it says thank you, and then moves on. Otherwise, it's got what's called linear control flow. How did this program execute? Did it start at the bottom and go up? No, that's not how we read. We read top to bottom, left to right. Programs are exactly the same way. With the main entry point here, you have linear control flow. This gets executed first. Then this gets executed. After that gets executed, this gets executed, right? And so on, right? But the main is that main entry point, right? Programs are executed in order, top to bottom, left to right, right? Just like we read in English, right? Not all languages are like that, but for better or worse, the English-speaking world dominated computing early in the computing history, and that's what we're left with, right? All right, what else do you see here? Other observations, or before we look at everything else here, let's go ahead and look at other observations. Punctuation, there we go. All right. So for example, in plain old English, we have punctuation, right? If you start a sentence and end a sentence, what comes at the end of a sentence? A period. So over here in the programming world, how do we end each sentence, which is an executable statement here? Another executable statement, another executable statement. How did we end each one of those? With a semicolon, right? So semicolons act like sentences. Sentences? I don't know how to spell it. And that looks wrong. There we go. There, that's right. My spell checker corrected me. Act like sentences. They end each executable statement. Right? And that's strict, right? If you put if you wrote an English paper and then you erased all of the periods, right? Would that be very readable? No. And you'd get marked off for it. Well, not only do you get marked off for it in terms of the compiler. If you don't have a semicolon at the end of somewhere, then it's a compiler error. And it'll say, error, I expected a semicolon at the end of that. Well, if you expected it, why couldn't you put it in there for me? It doesn't work like that, right? It's not predictive. It's not going to say, okay, I think you meant to do this over here, so I'm just going to go ahead and do it for you. You can get into some serious trouble with that, because what do we all say about assumptions, right? Don't assume anything, right? All right, and so we don't want our compiler to assume that we knew what we were talking about. We want to make sure that we're absolutely clear to the compiler. Right? What other punctuation do you see? Parentheses, right? Up here and over here and down here. When I make a function call, What can you observe about every opening parenthesis? There has to be a closing parenthesis, and it has to be good. It has to be where it needs to be. Again, if I don't do it, it's going to say, what are you talking about? Did you mean to put in a parenthesis there? Because compilers are dumb. And they're not, they can't make predictions. We don't want them to make predictions, because then they will predict things wrong, and then everything goes wrong. So I'll restore that. Parentheses, what else do you see? Brackets. Square bracket, opening bracket, and guess what? If you have an opening square bracket, or not square bracket, but opening curly bracket is what we call these, what else do you have? A closing curly bracket. Right? So curly brackets denote code blocks. So here's the main function. Everything between this opening curly bracket and this closing curly bracket is the main function. What is that analogous to in plain old English? If I've got sentence, 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 and I collect all these sentences into one unit, what is that called? A paragraph. So code blocks are kind of like paragraphs. Right? There we go. All right. What else do you see? Hint. Commas. What do we use commas for in English? To separate lists of things. Likewise, in code, we do the same thing. Commas delimit lists of items or things. Right? In general, white space does not matter to a computer. A computer. There we go. Right? In other words, I don't need all this needless double spacing here. In fact, I don't even need these comments. Let me go ahead and make this really, really compact. I could go ahead and take out all white space here. In fact, I can take that line and put it on that other line, right? You could do this in English. It's just that, is it readable at all anymore? No. This is definitely not going to be readable. We call this uglification. And in some programming languages, you do this. For example, like JavaScript. JavaScript is not compiled, so you would take your nice-looking source code and you would uglify it by taking out all the white space before you send it over the internet to somebody's browser. Why? Because if you're transmitting needless, useless white space over the wire, you're wasting bandwidth. Right? It's going to be much quicker if you remove all of the spaces, all the unnecessary spaces, and transmit that over the wire. Now, is that something that you are jazzed about reading and understanding? No, right? So white space has a purpose. White space doesn't matter to the computer, but it does to humans. Right? So let me go ahead and undo all my, I can undo this, or I can use a utility to do it. A style KMS 2 miles. There we go. Let me close this and open it back up. Ah, a little bit better, right? So what is A style? A style is a utility that stylizes your code. It'll go in and make sure that everything is consistent. For example, why do I have 1, 2, 3, 4 spaces here all the way down? Right? So now don't think about this as a paragraph anymore. Think about it as a bullet-pointed list. Here's my list of 4 things to do today. Okay, I'll break up that task into 3 things. I've got a sublist. That has a sublist, sublist, sublist. Or an outline in a paper. What do you do with an outline? You indent. You indent and you indent. And you make sure that everything is at the same indentation level. Right? I would argue that this is not entirely readable. I do like vertical spacing as well. Right? So let me go ahead and restore it down like this. Now, if I just went ahead with double spaces everywhere, you do that in English, right? Why? You need to write a 5-page essay. What do? You write a 3-page essay and then you double space it. In fact, there is unfortunately a measure of software productivity called LOCs, lines of code. We'll pay them by the number of lines of code, or whoever gets a raise. We'll determine raises by whoever has written the highest number of lines of code. That's a perverse incentivization. Why? Because now I have an incentive to add in unnecessary lines of code. I'm double spacing everywhere. In fact, I'm triple spacing, right? Because now I'm being paid by the line. I just got paid triple, right? Don't do that. It makes it completely unreadable, right? Just be consistent about it. For example, these 2 lines of code where I'm reading something in and then I'm immediately printing it out, I'd argue those 2 kinds of things are so related, I'm just going to go ahead and put them here with no vertical line. Whatever style you follow, just make sure that it's readable, make sure it's reasonably readable, and make sure that it's consistent. Okay? So it does matter to humans. Indentation gives an indication of code blocks. Right? In fact, in a programming language like Python, indentation is required for code blocks because you don't have the opening and closing curly brackets. Right? Other white space makes code more readable, and therefore easier to maintain. Right? And of course, there's always an exception to the rule. If you want to uglify your code so that it's difficult for other people to read, or because you want to transmit it over the internet and not have to send useless white space bytes. Right? Okay. Questions so far? No? Then we're going to skip the variable declaration here for a second, and we're going to immediately jump to this printf statement and this scanf statement here. Right? In fact, we'll do with we'll look at the output statement first. So output. Right? Output in C is done using printf. Right? The F stands for formatted. In other words, we're going to format our output. And what do I mean by that? Well, let's take a look at the code over here. And I've got this thing right here called %f. That's what's called a placeholder. When it actually got executed, let's execute it again. Right, there we go. And ran 5 miles this morning. There we go. It didn't actually print out %f, did it? Instead, it took the 5 that I entered into the computer and formatted it into 5.00006 zeros by default. Likewise, it did the same thing for this other placeholder over here, %f. F stands for floating point number. I want to print a floating point number. And it formatted that output for me. Now, up here, there was no formatting at all. Right? There were no placeholders here. It was just printing out a pure string, just like Hello World yesterday in your lab. Okay? Some observations about that. Again, it stands for formatting. Formatted output can use placeholders. These placeholders are the common ones that we're going to use are %d, %f, and %s. All right, there we go. What are they for? %d is for integers. Right? And we'll get to this in a second, but anytime you want an integer in C programming, you want an int. Right? Whole numbers, including 0 and negative. So for example, I'll go into math mode here because it's just cool. -2, -1, 0, 1, 2, ... on to infinity, both directions. That looks nice. There we go. Right? So all integers are like that, except that computers are finite. This is an infinite sequence here, right? Is there a largest number? No, that doesn't make any sense. But is there a largest memory? Yeah, right? This only has what? Maybe 4 terabytes of memory or something like that. In other words, I can only fit so much information on a computer because computers are finite. So how do we deal with that? I could fill my computer up with the biggest number that I could, and then I need one more digit to represent it. It ain't happening, right? So how are we going to deal with that? We'll deal with that when we get to actual integers here, right? Otherwise, %f is for floating point numbers, right? That is fractional numbers, like 3.14159, right? Or 10.0. That is a fractional number. It's just that there's no fraction there. Or 2.5. Right? So for those examples. Another placeholder, I should have added this placeholder up here, %c, there we go, is for characters. %c is for single characters, right? Emphasizing that. Hello world, is that a single character? No, it's a bunch of characters. HELLO, space, that is a space is a character. WORLD, exclamation point, end-line character. There's a whole bunch of characters there. Right? That's not an appropriate placeholder for that. A single character would be like C, all right, for my first name, B for my last name. Right? So that's for single characters. Right? Scanf, and these things are, as alluded to in your lab yesterday, anything worthwhile in computer science is case sensitive. Scanf is not the same thing, or printf and scanf are not the same things as, say, printf with a capital P, capital S. This will not compile. It does not know what you're talking, GCC, there we go. It does not know what you're talking about. Capital S scanf is not the same thing as scanf. File names are the same way. There are, consumer end products that make no distinction between uppercase and lowercase, and it'll find what you're looking for. If you search on Google for, Chicago Cubs, right? It's not going to care if it's capital C, right? It's just going to care that it's going to search for that for that no matter what, right? But over here in programming, everything needs to be precise, and if it's got to be precise, casing matters. We call it case sensitivity. So it has to be lowercase s, lowercase p. All right. So scanf is used for input. For now, all the placeholders are the same, except ... For floats, that is fractional numbers, you use %lf. Technically, that stands for long float. We'll talk about the difference later on. And for now, what is this thing? What is that? What is the proper name for that thing? It's the ampersand, right? Now, in plain language, we've used that for and, a placeholder for and. Just like above the to key on your keyboard, that's an @ symbol that's used in email and stuff like that. This is an ampersand, right? For now, the ampersand is just magic. Right? It's got to be there. Let's take a look at the scanf here. Right? So what it does is it reads in from the user, LF, meaning a floating point number, so that I could have, let's go ahead and run this again. Instead of running 5.5 miles, I could say, well, I ran 5.5 miles. Right? And it would still work. 5.5 miles is a little bit more than 8 kilometers. Right? That is a floating point number. I can have fractional values here, but I have to use LF. And then I specify the variable that I want you to put the result into. Why am I doing it like this with the ampersand out front? Again, magic for now. Ampersand is actually getting the memory address of that variable so that it can pass it by reference. We'll get to that much later. Right? For now, just remember, if you do not have an ampersand there, it will compile. It won't give you what you want. Let me go ahead and show you what I mean. Right? First of all, is that an error anymore? No, it's just a warning. Warning, something's wrong here. This is legal, but you probably didn't mean to do this. Right? And in fact, on CodePost, for every single submission, we have 2 tests that are ungraded. Because if nothing compiles, nothing works, it's going to be 0 anyway. So the first test is, does it compile? The second test is, are there any warnings generated like this? Because you need to know about it. Right? And if there are warnings like this, you probably need to fix them. And the problem here is, what it expects, it's not that clear. A double star, what is that? I don't know what this is. For now, that should just be your strong indication that, what did I forget? The ampersand. Because if you don't go back and fix it, the program will run 5, but is it going to give you what you want? Nope, 0 and 0. Okay. Well, that's true. 0 miles is equal to 0 kilometers, but did it actually read in my input of 5? No. You're just going to get unexpected results. Right? So I'll restore that. For now, the ampersand is just magic. Let's see. All right. So with our 5 minutes here, let's go ahead and look at those variables. First of all, I'm going to observe a fact of life here, that C is a statically typed language. Right? Statically typed. Right? Not typed as in I'm sitting here typing on my computer. Instead, type as in what kind of variable is this? What type of variable is this? And there are several different kinds of variables that we're going to start out with. Int is an integer. Right? Double is a floating point number. That is a fractional value. Right? And finally, the other one that we'll start out with, we'll look at more later on, HR. What do you think that stands for? Int is kind of explanatory because it's just short for integer. Double, how do you get a double out of a floating point? I don't know what that means, but char, that should be pretty clear. What should that be short for? Is a single character. Right? So if I want to store my initials, CB, right, then I would need 2 char values there. Right? What does it mean to be statically typed? Statically typed means that before you can use any variable, you must declare it. That is, you provide the type, right, int, double, or char, and a legal name. Right? So, and hopefully a good legal name. Right? So let's go ahead and take a look at my program again over here. I've created 2 variables. One of them is called miles, and one of them is called kilometers. What if I didn't do that? Right? If you've ever done any Python programming or JavaScript programming or PHP programming or programming languages that are not statically typed, you can just go ahead and create a variable and start using it. In fact, you don't even specify its type. Later on, you can change its type, right? Those are called dynamically typed languages, and trust me, they're more trouble than they're worth. Thankfully, we've got statically typed language here because the compiler is able to catch errors like this. Like, wait, what is miles? I don't know what that is. Is that an integer? Is that a double? Is that a char? You need to tell me. So I'll restore that up here and say, well, miles is a variable of type double. KMS is a variable of type double. Right? What if I said kilometers? There we go. Is that a legal variable name? Let's find out. It's automatically saved, so let's go ahead and try it. Nope. Kilometers? What is that? Right? You cannot have spaces. Right? That's why a lot of times you'll see a placeholder for these instead. People do like spaces. But what's the most appropriate thing that's not a space on your keyboard? An underscore, right? That's called underscore casing. I don't like it. I'm probably not going to use it. Instead, I'm going to use upper camel casing, lower camel casing, which is kind of like this. Let me ask you, though. I wrote out, the other option there was to write out kilometers. This one is KMS. Which one's better? How about, well, here, let's get something that's really obviously bad. What if I just said X and Y? Or you'll get into the habit of doing it because all computer scientists do, a placeholder variable name or a placeholder function name, foo and bar, right? And then after that you get baz, biz, and any variation on those, right? So what about foo and bar? Are those good variable names? What does foo stand for? What does bar stand for? Yeah, well, if you know what it actually stands for from old school military speak, then great. Just don't voice it out. Miles and KMS, right? So what about X and Y? Are those good variable names? Well, mathematicians do that all the time, right? Mathematicians use X and Y for the Cartesian coordinates, right? Well, why is that? What is the grid representing? They're mathematicians. They're thinking abstractly. It's representing x squared. Well, what is x squared representing? I don't know. Who cares? Right? I'm a mathematician. But we do care. We care that our variable names stand for something because we have to read the code. And I don't want to sit there and have a guesswork of, what was x again? X was miles. All right, then that was mean that y is kilometers. Okay, dot, dot, dot. 5 minutes later, I get them superimposed again. Right? Was it miles or kilometers? I'm always having to look back. But if I say miles and KMS, that's a little bit better still. Right? What about KMS or kilometers? Right? Which one would you argue is better? Now here's where it can be kind of debate. Why? What are the arguments for KMS here? KMS, faster type, right? Great. What are the arguments against that and for kilometers? You know for certain what it is. What could you misinterpret KMS as? Kilometers per second, right? Or maybe you've never even heard of miles. Hopefully not, because we should be in the standard system there. But KMS, what is a mile? Anyway, right? Miles or kilometers. I would argue that, and that's why I started out with KMS so that we could improve it. Let's go ahead and change our variable name here to kilometers. Okay. Now, if I change it here, where else do I need to change it? Everywhere else that I have it. And there are some tips and tricks in modern, in like the desktop version of this. What you could do is you could right-click it and say rename the variable, and it'll rename it everywhere for you. I don't know how to do that. There is a way. There's a quick key, but I forget what it is off the top of my head. But there is a way to do that. You could say rename this. What is it? Nope. I forget what the quick key is, but you could go ahead and retype this, and it'll be retyped everywhere, right? But I'll look that up later on. Kilometers. Right? There, oops. And then, of course, you have to make sure that everything is spelled correctly. If I don't spell something correctly, it will find me out there. Kilometers. Make sure that you're spelling everything correctly. All right. We'll pick it up there on Friday.